Okay, I'm going to do a few examples of solving rational equations from the packet. All right, so when I look at this, if I get a common denominator all the way across my equation, then if I multiply by that denominator, it's going to cancel out. So this one, the only thing it needs is a 2. So whatever I do to the top, or to the bottom, I have to do to the top. So I get 2m plus, I'm distributing this, 2 times m is 2m. All right, 2 times 4 is 8. Plus m plus 1. I'm just basically putting this all together because I have a common denominator now of 2m. Now, whenever you're dividing both sides by the same thing, you can just cancel it out. But technically, the step of algebra to show why it cancels out is you multiply both sides by 2m, and really that's 2m over 1. Since this is on top, this is on bottom, and this is multiplication in here, we know that that crosses out. Same thing, when I multiply that one by 2m, those two cancel out. So what I'm left with, the moral of the story is that I'm left with the top of the fraction, which has not been changed. All right, and then we collect what we can, so we have 3 m's. Looks like plus 9 equals m plus 3. And I'm just going to do 2 steps in one so I don't run out of room. I'm going to subtract m from both sides, and I'm going to subtract 9 from both sides. So that all comes out to 2m equals, that's negative 6. So m equals negative 3. You can always check your work. All right, you can take this, plug it back in, and see if it equals, if the left side equals the right side. Okay, number 4, I skipped a couple, but this one is not as hard as it seems. Really, all you have to do is, this has 3 and this has 3x, so this one needs a 3. So if I multiply this by 3 and this one, now I have a common denominator. So on the left side, I have all over 3x. I have 4x plus 1 plus this whole quantity, and it's multiplied by 3. So 4x plus 1 plus, I'm going to go ahead and distribute this 3. So 3x squared plus 9x minus 30. And over here on this side, I have 1 over 3x. Again, if I multiply both sides by 3x, it's going to get rid of the fraction altogether. So I'm left with, see how I'm left with just what's up top. So I have 1 equals, if I collect this all together, I have 3x squareds, I have 13 x's, and I have negative 29 constants. So collecting like terms up top, and then I have a quadratic. To solve a quadratic, I must get it equal to 0. So I'm going to subtract 1 from both sides, and I have 0 equals 3x squared plus 13x minus 30. Okay, there's a lot of different ways we can solve a quadratic. We can solve it by using the quadratic formula, or we can solve it by factoring. This one looks like it factors. It's really not that hard of one to factor, but if you're not that great at factoring and you need a way to solve this, you could use x equals negative b plus or minus b squared minus 4ac over 2a. That is the quadratic formula. So go ahead and use that if you want. I'm not going to show it here because there's only one way to get 3x squared, and there's only a couple ways to get negative 30. So I need 13 in the middle. So if I think about this, if I get 18 here, 3x times 6 gives me 18x. And then I subtract 5x. If I look at the middle there, I'm going to get 13x. So you're just going to have to guess and check there, see what makes sense. But I just noticed that I was thinking about 5 and 6 as a factor of negative 30, and 6 times 3 gives me the 18, and negative 5 times 1, or times 1x is negative 5, so 18x plus a negative 5x or minus 5x gives me the 13. Regardless, I'm set up to solve this. So now I got to set this one equal to 0. Really got to set both of them equal to 0. This one's a lot easier to think about. That's x equals negative 6. This one you add 5 and divide by 3. Think about that. The 5 becomes positive, and then you divide by 3. So we get 5/3 and negative 6. Okay, number 5. Now, my common denominator is going to be 4x squared. Okay, so this one needs an x squared. I'm going to multiply the top and bottom by x squared. See, now it looks similar. This one has 4x, but it needs another x. It needs to be multiplied by x to get 4x squared. So whatever I do to the bottom, I have to do to the top. So you notice that I multiplied that whole quantity by x, not just the x or just the 2. You have to multiply both of those. So let's rewrite this. I'm going to actually distribute that, so I get x squared plus 2x over 4x squared equals x squared times 1 is just x squared. That one I didn't have to mess with. Alright, so there's another way. You don't always have to combine this. So you could go ahead and do this step by, to get rid of the 4x squareds on the bottom. You can multiply, both sides by 4x squared. That's going to cancel. If you do it like this, if you keep it separate, make sure you cross out everything. Right, again, we're only left with what's up top. So I have x squared plus 2x equals, I write this as x squared minus 1. Now you notice I have x squared on both sides. If I subtract x squared on both sides, those are both going to be 0. So I'm left with x equals negative 1. Oops. So divide both sides by 2. X equals negative 1/2. All right, number 6. Your common denominator here, some people are having some troubles with this, is I have an x, I have an x plus 2. Now, it would be great if I could just add 2 to this and add 2 to this, but you can't do that. That's not mathematically sound. That's not an equivalent fraction whatsoever. So to get an equivalent fraction here, we have to use multiplication, all right, to find a common denominator. So when in doubt, when you need a common denominator, you can multiply the two together. And that's what we're looking for. We're looking for x and x plus 2. All right, that's our least common multiple also. All right, so before we get there, we have to make these look the same. So if you look down at what our common denominator is, this one needs an x plus 2, this one needs an x. All right, so I'd like to rewrite, so I'm going to write it over here. So this becomes 14. You need an x plus 2 on the bottom, so you got to put that up top. Plus, this one needed an x. You notice that I multiplied the x up top to this entire quantity, not just the 8, not just the negative 7, the whole thing. Okay, so now that equals 1. So if I look at this, if I put this all together here, I might actually go ahead and distribute that. So I get 14x plus 28 plus x times 8x is 8x squared. And then x times negative 7 is negative 7x. Okay, so I could collect this stuff here. So kind of running out of room. I have 7x. I want to write the 8x first. I have 8x squared plus 7x plus 28 equals 1. All right, sorry. This is kind of sloppy, sorry. So I have this all going for me now. Think about this. If I have something divided by another thing and it equals 1, don't these two things have to be equal? 5 divided by 5 makes 1. So two things that are equal when divided make 1. So I can just go ahead right off the bat and set these two equal to each other. So I have 8x squared plus 7x plus 28 equals this, and I'm actually going to go ahead and distribute that. So I get x squared plus 2x. All right, I have a quadratic, so to solve it, I need to subtract x squared from both sides and subtract 2x. So I'm left with 7x squared plus 5x plus 28 equals 0. Now, I'm not going to take the time to see if this is factorable. I'm pretty sure it's not. So if you've tried to factor this thing and it's just not working out, go ahead and use the quadratic formula. So the quadratic formula is negative b plus or minus b squared minus 4ac over 2a. And what happens when you plug in this part, five squared is 25, so I'm just going to write it like that. So I get 5 squared minus 4 times 7 times 28. You get negative 759 underneath there. Over 14. So yes, I am going to get an imaginary solution here. Remember, this is x equals. So my x is equal negative 5 plus or minus I radical 759 over 14.